Hello and welcome to Learn Data. I'm Nilesh and today we'll continue talking about pandas and particularly we'll work on categories, and in this final video on categories we'll look at how to access categories, and while doing so, if they change their data type, how do we bring it back and make them categories again. Also, we'll look at the operations concatenate and union of categorical data and see how the data type works in these two cases as well. So let's get into Jupyter notebook and start coding. I've already created a new notebook and imported two libraries, NumPy and Pandas. And for data type, we have just simple items here. One index, which is list of 5 elements, and then we have two series. One is A and the other one is A1. The A1 is of categorical data type, as you can see here. Then we have a data frame which uses the series A1 to create the column cats. So as you guessed, the column cats is a categorical column, as we can see here. Now let's get started in using iloc and see how we can access categorical data from the data frame, and does it have any restrictions as to how we can access, or does it change any type of category. So for df.iloc, let's say if we want to access the elements from positions 2 to 4 and all the columns, then we can get this is the resulting output. And here we know that the cats column is a categorical column, so why don't we put this in a variable x and then look at, so here we can go ahead and print x.dtypes and we can print x. So as you can see, the cats column is a categorical column. Even after we took a slice out of the data frame, the column continues to bear the data type category. Okay. Similarly, let's look at what happens if we use the loc command. So df.loc, and here we are going to use the labels. So let's use the label I to j, and again we'll use all the columns. Now if we print the x.dtypes and if we print the x, we can see that here also we do get the category column back in the output. So the nothing happens to the data types, the category stays as is. Now however, things are going to change. Here what we are going to do now is we are going to use df.loc. The label we are going to use is I, but the difference is here we are going to pull just one value and from the column cats. Now when we do that, if we print x dot, if we print x, here we can see that we just get the letter O back, and if we look at the type, what we are getting is a string. We are not getting the category back, even though O is a category in the data frame. If we go back and look up here, O is a category. However, when we pull just one value from the category column, it no longer stays as a category, it gets converted to a string. Similarly, if we use other means of pulling the data, for example, if we use df.add, and here as you probably remember, we need to use labels, and if we try to use the cats, now if we print the type of x and if we print x, we see that again what we get back is a string and not a category as we did in the very early two attempts that we tried. Now what should we do to get a category back when we are using just one, when we want to access just one of those items, one of the categories? The way we would do that is using the square brackets around the label. So if we have df.loc, then here within square brackets would specify the label, which is I, and for the column name we are going to specify cats. Now when we print x, what we get is a category back, and it is associated with all the associated categories M, N, and O. Now if we look at type of X, what we are essentially pulling back is a series which comes with the index I, and we have just one value of the category from that column. Similarly to this, we could also have, if we are using iloc, so let's try that again, df.iloc, and here if we use the indices for the rows, then we need to use the index for the column, and when we run this, we do get two items back, and they again are categorical data types. So that was the important point to make, that if we pull more than one, then we usually get a categorical data, we preserve that data type. However, if we pull just one, then it can get converted to a string, but if we need it to stay as a category, then we could pull it as a series. Now what happens if you try to compare return values? What I mean by that is, let's say we have if we are looking at the series A1, and from here if we check if it contains the string M, what we get is there are two positions which has the string M. Okay, now the return value for this is, if you look at just the data type, it's a boolean, so we get a boolean back. Now if we want to compare the return value, if those are the same, then we can compare them irrespective of what source they came from. What I mean by that is, we got that boolean from a series that was a categorical series, and here the second case we have a boolean that we are getting from a series that is an object series. So it doesn't matter. If we compare these two, then we get that those two are the same, so we get a value of true in return, as you can see here. So moving on, now let's look at another cases where categories can be used, and one of that is dates and creating a column or a category of dates. So let's put here dates. Here we are going to create another series B, pd.series, and we'll add a date range, so date underscore range, and this date we are going to use is 2020, say 01, 01, and periods is equal to 4, so we'll get just 4 dates from there, and the data type will specify it as a category. Now when we print B, that underscore, sorry, so okay, generate data type, D types, oh sorry, this has to be there. Now, so the series that we have here is of data type category, and it has these four categories which are distinct dates. Okay, now if we were to get the year from here, this, so if we put that in a variable x, b.dt.year, and if we print type of x, and if we print x, we can see that it is converted to integer, and it's no longer a series. So if we it's no longer a category. So if we are working in situations where we are extracting a new value from an existing date category, then the output may not always be a category. So in this case, what we are getting is an integer. So that is just one thing to remember. Now let's get back to the data frame that we were working with, and there we'll look at how important it is to have matching categories when we are trying to update a data frame. And I'm going to create new cells here. Okay, So the data frame that we have is this. Now let's say at positions 1 and 3, so 0, 1, 2 and 3, 0, 1, 2, 3, so maybe 0, 1. So at positions here N and O, if we want to remove those and put values L and U instead of N and O, and instead of 3 and 4 if we want to put 99 and 999, the way we would usually do that is by using df.iloc 1 up to 3, so the indices, and then all the columns we are going to make the change, and then here we specify this is the new category that we want to put in, and this is the new value for num that we need to put in instead of n and 3, and similarly value of u and 999 instead of the value O and 4. However, we'll get an error when we run this, and the reason is because the categories are not there, L and U. So the reason is cannot set item on a categorical with a new category, set the categories first. So the problem here is that when we look at the data frame F, and if you look at the column category cats, here we can see that the category L and U do not exist in this particular data frame. Therefore, it's not going to work. What we need to do before we can make any changes to this data frame is add these new categories into the data frame. So let's go ahead and do that. So df.cats, and here we can go ahead and add that df.cats.cat.set underscore categories, and now we can go ahead and specify all the categories M, then we have N, O, and we have P. Now we can put the new value of L and U. So because we now have put all these values, now if you look at df.cats, we can see that these two values now are included in the data frame. Now if we run this, then we are able to successfully update these two positions where we replaced the N and O with L and U and corresponding values in the num column. So that is to show you that if we have a particular category, and if you want to update that category and put in a new category, categorical value, then we need to have that new category associated with that data frame beforehand, and we can use the set underscore categories command to make that happen. Now if we want to replace these values of L and U in this particular data frame, if we try the following, we are going to get an error. So let's see, df.log, and we'll use the labels F through I in this case, and we'll use the label for column cats. Now pd.categorical, and here we specify M and we specify N, and then we have the categories, and in categories we are not going to specify all the categories. So what we'll specify is just M and N and something new which is Q, and when we run this we get an error which says cannot set a categorical with another without identical categories. So this is important, identical categories. So what Pandas is looking for here is, in this particular part, it needs to have exactly the same categories that are currently existing in this data frame df. So what categories are existing here? Let's go ahead and check. So we have categories M, N, O, P, L and U. So we need to put all these categories right here and then run this. So let's try that. So I'm gonna put quotes around all of these, M, O, P, L and U. Now once we have all the categories in there, when we go ahead and run this, now if we look at the df, we see that we put back M and N in those two positions where there was L and U, and the values in num stay as is. So that's another thing to remember, is that it's very important to have all the categories in case. So we are dealing with unordered categories right now, and even in unordered categories we need to at least list all the categories to make the change happen in the data frame, as we saw here. Now let's look at how we can concatenate series that has categorical data, and if it has an effect on the output. So let's go ahead and create a series A2, which is pd.series, and we just have two categories in there, F and D, and we'll call this data type is equal to category. Now in addition to this, let's create another series A3 pd.series, and for this we are going to create another categories D and F, and again this would be the data type is equal to category. Okay, so what we are going to do now is trying to concatenate them. We have the earlier series A1, we have A1 which is a category, then we have the series A which is not a category, then we have the series A2 which is a category. However, it has different categories than A1 and A2, and we have the series A3 which has categories that are similar to A2, but they are different than A and A1 that we had in the very beginning of this notebook. So what happens if we concatenate? So if we concatenate two series, which is A1 and A2. So in this particular case, what's important to remember, we are concatenating two series that do not have same categories. Okay, so when we do that, we do get concatenation successful. However, what we see is that the final output data type is an object, it's no longer a category. So the values from the series A2, which were F and D, those were categories, but now they are converted to an object. And here, if we want to preserve that particular data set as a category, then we need to explicitly specify that they need to be astype category, and only after that we get the output as a category. And the categories here, we can see that DF is added with M, N and O, so we now have a total of 5 categories when we join two series with dissimilar categories together. Okay, similarly, if we have two series with similar categories, what do we get in the output? pd.concat, and here if we concatenate A3 with A2, we do get a category back. So that's the difference. If we have two series that both have the same categories, then the output is a category. However, if the two series that we are trying to concatenate have different categories, then the output is an object. Okay, so that's the main takeaway point from that exercise there. Next, let's look at how we can use union, and does union have a similar effect or a different effect when we are combining categorical data. So categories, let's make it marked down. Okay, for this we are first going to import a library called from pandas.api.types import union underscore categories. Okay, so union underscore categoricals. Sorry. Okay, now if we use the union underscore categoricals, and again we pass a1 as an array and then pass a2 as an array, in this case, contrary to what we saw earlier, the output that we get is a series, is a list, but it's categorical. As you can see here, the structure of the data type, that it's a category, is preserved in the output. Okay, and we can put this in a series variable x. We can also look at print type of x and then print x. So as you can see, what we get back is a categorical as an output, even if the two arrays or series that we started with had different completely different categories. Similarly, let's look at another example where we do a union. So x is equal to union underscore categoricals, and we are going to use the a3 this time dot array against a2 dot array. Now these two, we saw in the previous example that they did have the same categories f and d. Now when we run this here, we do get the categorical out, and those two are preserved as categories in the output. Okay, now moving forward, let's see how we can sort categories. So why don't we copy this example up there and put it down here. What we saw earlier was that these categories in here that we see, they were not ordered, but we can change that, and we can say sort underscore categories is equal to true. What this does is, in the output we can see that these are now sorted alphabetically from D to O. Okay, moving on, let's look at numeric categories and how does that work. For numeric categories, we'll go ahead and create integer category series. So pd.series, and here let's say 1, 2 and 3 are 3 categories. We'll specify the data type as category, type as a category, and we'll create another series which is a float, pd.series, and here we are going to convert it to float. So instead of 1, we'll type 1.0, 2.0, 3.0, and we'll specify this also as a category. Okay, so those are the two new numerical categories we have. Now if we go ahead and concatenate these two in the same way, a int and a float, what we get in the output is a float. We do not get a categorical column out. Okay, and here if we want to convert them to a category, then what we need to do is specify as type and then specify category, and only after that we get these as categories, but they are float type. So float categories is what we are getting back. And if you are wondering what happens if we combine two numerical categories that are both integers, let's go ahead and quickly try that. So I'm going to put 2 there, and if we can just copy that, paste it here, and a int 2. Let's run this, and here you can see that if they are same, if both are integers, then the output that we get is also integer category, and there's no conversion to float in that case. Finally, let's look at situations where we need to order the categories, and does that change anything. So ordered categories. Okay, let's remove that M. A1 is the series that we already have created. We'll set that as an ordered series, So a1.cat.as underscore ordered will do that, and when we run this we can see that M is the smallest category, O is the largest category. So that's how this will work. We'll go ahead and make that change to other two categories as two series as well, A2 and A3. So now what we have done is we have ordered all those categories. Now if we run the union underscore categoricals and specify A3 and A2, when we run this it works because in both A1, A3 and A2, so let's pull A3 and A2. In both A3 and A2, the categories that we have, they are ordered, they are the same categories, that is correct, but then they are also ordered in the same way. So D is the smallest and F is the greater than D. So that's why we are able to do this union of A3 and A2. Now if we try A1 and A2, we are going to get an error. Union underscore categoricals A1, A2, and the reason why we are getting an error is because the categoricals, the union to union ordered categoricals, all categories must be the same, and the problem is in A1 we have M and O, and A2 we have F and D, so they are not the same, and therefore this does not work. In previous union that we did, both the series were not ordered, and therefore that union was possible. So here, to make this work, what we need to specify is ignore underscore order is equal to true, and after that then we can successfully union the two categorical series that we have, A1 and A2. Okay, finally let's look at codes. We'll go ahead and create two series. W1 is equal to pd dot categorical, and we'll have M and N, and then we'll copy this, paste it here, 2, and here let's put N and O. So we have these two series, W1 and W2. Now if you get the codes for W1, what we get is, if we get codes for W1, what we get is 0 and 1. So M is coded as 0, N is coded as 1. Similarly, if you look at W2, we see that in this case N is coded as 0 and O is coded as 1. So there is a difference. So the category N is coded differently in each of those two cases. So when we do the union, it can pick up a new value. So union underscore categoricals, and here if we specify W1 comma W2, and if you look at the codes, now we can see that the N has taken up values 1 and 1. So that is just one thing to remember, is that when we are combining two series that has categories in them, and when we are coding, the numeric code that is generated after the union could be different than what the numeric code would have been if they were coded individually before the union. Okay, so W1 and W2 had the codes of 1 and 0 for N. They were different, and after union, N took the code of 1. So that's just to remember when working with coded categoricals. That was all for this video. I hope you all learned in this past 4 videos how to handle categorical data. and this is going to be really helpful when we are working in future projects, when we are doing some segmentation. Please like, share and subscribe. It helps me stay motivated to create more content for you all. I've also started a new playlist for quizzes. I hope you enjoy that as well. Thank you, and I'll see you all in the next video.